before we jump into the simulation, you see there are a bunch of other inputs that we have to put in here. So for instance, the first one is VEA object that is coming from our EPV files, right? So we can come over here and then see this VEA object from EPV, right? We need to connect an EPV here. I already created a location file from the map that we always use. And we do the same thing, EPV download data, and we connect the EPV data here, and we create the VEE. So VEA is the file that we are using is to define our location for this analysis. Okay, time step should be 1. It is 1 for now. Okay. North is north and thresholds. So things are getting might sound a bit complicated here, but trust me, it's not complicated at all. So the threshold is the values that we are putting for the luxes. Lux is the basic unit for light and daylight, obviously. And this threshold is basically determining some outputs, such as UDI, useful daylight illuminance, or daylight autonomy. These things are defined by the lux values alongside with the times that we are using. So for instance, this is our space, right? And imagine on this space, if I preview everything off, we get some results, right? Some results of some colors, some percentages, and so on and so forth. So daylight autonomy is going to tell us how many or what is the percentage of the time that we are receiving the value of the threshold. So if our threshold is 300 for now, it's going to give us the results on the locations where we are receiving, like, let's say 55, which will mean that that particular location will get more than 300 lux over the time, or over the 55% of the time. And that time is actually defined by the schedule over here. Okay, you can define your own schedule by coming to Honeybee Energy tab here. Here, I think, yeah. And then you can define your own schedule. And these schedules can be looked amongst the Honeybee's schedules. You can create a constant schedule, fixed interval, seasonal, so on and so forth. We can leave it as it is for now. Grid filter, we don't need to put anything here, or radiance parameters, we don't need to worry about this. Enhance, we can leave it as true. Run settings, we don't need to worry about that as well. And then we will have run. We can put a LV false toggle here. And when we run this, we are going to see that our screen will pop up. Okay. And this is going to give us some results, but what are those results would be? So I'll be explaining those results to you in a second with showing you a bit more information from a presentation that I made a couple of years ago on daylighting. And we'll go through all the information that it's going to give us as our results. So let's wait for a couple of more, maybe seconds. And at the same time, when I'm recording this and when this simulation runs, things get a bit slower, that's for sure. And I think we are almost there, hopefully. Yes, so we now have our results, right? And those results it takes 1.3 minutes to have the results. And results now are defined as results here. But you see, we have also results for daylight autonomy. And we have 1,700 and 94 results for that, which is quite close to what we have as our grid, right? We have this amount of points here, and we have this mesh over there. So what is this daylight autonomy? If you hover over, you'll see that there is an information related to that, but I want to show you this one. So that's the previous screen is where it's record my voice as a text. So daylight autonomy is basically a metric that corresponds to the percentage of the occupied time, right? As I said at the beginning, when the target illuminance at a point in a space is met by daylight, meaning if you take a closer look at these locations, so this means the blue means let's say 0, right? Or let's say 10. It means it receives 300 lux 10% of the time that we defined as our schedule. And if we are putting this like, in other words, if you put 300 lux as our target, and the threshold daylight autonomy of 50%, meaning 50% of the time daylight levels are above the target illuminance. That is basically something we are looking for, and it's basically promoted in the Illuminating Engineering Society of North America as well. And we are going to see some other outputs such as UDI, useful daylight illuminance, and that is basically quite similar, but it's actually related with what we can do with that amount of lux. So it's if it's below 100 lux, it's problematic. If it's 100 lux, it's acceptable, I think. The desired one is, I think, is something between 300 and 3000 lux, and over 3000 lux it's going to cause glare, which we'll define that in our later tutorials. So, but how we are going to visualize these results? So what I'll be taking first is the daylight illuminance, daylight autonomy. And this is the text, right? If I grab a tag and if I put my text here, and my location now is going to be these points, right? Sorry, these points. I can get this point in, and then I can say wire display hidden, connect this onto as my location. Obviously now I'm seeing everything a bit off, so one thing I can do here is to convert this preview on and maybe preview view off. Okay, and the points can be also preview off. The size of this is really small, we can make it really small. Okay, and how about, or how we can make this colorful? For that we can use Ladybug. We go to Ladybug and then LB color range and then spatial heat map. So these are my values. What is the mesh that I'll be running this analysis for is basically, this is the mesh that I'll be using. Connect this mesh here. Wire display hidden. I can put this here as well. And now what I'm seeing is I started to see a lot of different information here as well. And let me preview this off. So what I'll be doing here is basically changing the colors or create a legend parameter here. Okay. And we'll be putting like, it's ranging between 85 to 9.3 because everything is quite open here, right? And like, let's say if you want to only see between like 0 and 10, 0 and 100, which we need to take a look, right? And if you connect this over here as our colors, and let's say 3 to this, and put the legend parameters in, you see we have everything yellow because there's nothing we can change here, right? But if you take this to 9.5, it goes all, you see we have to have something in between. Like if we have it too much and we don't have much changing, maybe it's related to this amount of color. I mean, we can still get some values here, but they are basically ranging in between 80 and 100. So there's always like it's almost super like that's almost again you see it's almost super close to one another, so we can leave it as it is. But when we put 0 we don't see much, but that's fine. Let's leave it as this one, and we can put a legend title and everything as such to this. But if I preview this on and zoom in, you see what I'm seeing here? You see they're almost like the minimum one, let's say, is 80.84 or something as such. Like almost all of them is having more than we are, like having more than we can easily differentiate by our eyes. So that's pretty much it for this video. And in the next video, we'll be talking about how we can change this into a bit more, into a bit more differentiated results by playing around with our models.